This is Danny Tang. I'm doing the probability and stochastic homework number 11, problem 1. And problem 1 says that x of t is a y-sun stationary random process with an autocorrelation function that is periodic. So that means that r of tau plus n times period, capital T equals r of tau. So this is what periodic means. And we want to show that the linear estimator xt plus k of capital T equals x of t. So to do this, we use the hint given to us by the problem. So we can say that y is estimated by a and b, and then y hat, which is the linear estimator, is equal to ax plus b. And we can find what a and b are by minimizing the mean square error given to us by this equation, expected value of y minus g of x, all of it squared, where g of x is the linear estimator y hat. So to do this, we take the derivative with respect to a and b and set it to 0. And that's how we find what a and b are. And so we take the derivative here, dda and ddb, set it to 0. And then we take the derivative inside using the chain rule, and this is what you get. So for solving for error b, a and b, you would simplify these equations here and then set it to a equals and b equals. So a is equal to the covariance of x and y over these variance of x, and b is expected value of y minus expected value of x times covariance xy over the variance of x. So now we prove that the linear estimator y hat is equal to this expression here. So we put what we found for a and b into this ax plus b expression. Simplifying it gives us expected value of y plus x minus expected value of x times covariance xy over variance of x. So knowing that, we can now show that the linear estimator x hat t plus k capital T equals x of t. So we basically substitute x of t for x, and I didn't write it here, but x of t plus kt for y. So you get this expression here. So we can find what a is equal to in this instance. We take this derivative, set it to 0, simplify this expression here, and what you get is, after you simplify this, you distribute this out, you get this expression. The expected value of x of t times xt plus kt is just the autocorrelation of capital T minus a times expected value of x squared t times minus b expected value of x of t. So here we can't really go any further because we don't know what b is. And now we solve for b the same way. Take the derivative with respect to b, set it to 0, simplify this expression, and we get b is equal to expected value of x of t plus k capital T minus a of expected value of x of t. And since we know that x of t is WSS with a periodic autocorrelation, that means that these two expected values are equal to the mean of x. So this is eta x, mean of x. So we put this back into the equation since these two expected values are the same. So b is equal to mean minus a times mean. And then we can put in b back into the equation we found here, b here. And simplifying it gives us, for putting this in, and then we simplify, and then we set it to 0 because we want to find what a is. And a is covariance of k big T over variance of x. And this is equal to 1 because autocorrelation is periodic. So since we know that a is 1, we put this back into the expression. This goes to 1 because a is 1. So is this one. So it's just x of t plus 0, which is just x of t. So we prove that the linear estimator t plus k capital T is equal to x of t.